So a key to today's lesson is going to be the two sentences at the top here. That when we're adding terms that are happening to be in brackets, it's the same thing as adding each term one at a time. So each term, that addition is distributive. It's the same thing with subtraction, that when we're subtracting terms that happen to be in brackets, we are going to basically subtract each term as we go. So if we look at our first example, this might explain it a little bit better, in that I have this stuff in brackets and I have this stuff in brackets. And it just so happens that the stuff in these brackets, there are no like terms, and the stuff in these brackets, there are no like terms. There's actually a way to cheat BEDMAS a little bit. So with these first three terms, there's no operations happening for them, so we can actually melt away those brackets and say that that's the same thing as 3x squared minus 5x plus 4. And we can also actually melt away the second set of brackets, because if I'm going to add all of this, it's the same thing as adding each of these. So actually, if I add 2x squared, I'm adding 2x squared. That's pretty obvious. If I'm adding positive x, I'm adding x. And if I'm adding a negative 7, I'm actually just subtracting 7. So we would have been able to just fade away those brackets and actually get away without having to do BEDMAS. So if we collect like terms just like yesterday's lesson, 3x squared plus 2x squared, that gets us 5x squared. And negative 5x plus x, that gets us negative 4x, and positive 4 minus 7 gets us negative 3. So we can collect like terms that way. Now, if you actually use that substitution method of checking, so if you just picked a random number for x, substituted it into that original expression, and picked a random number for x and substituted it into that expression, they should actually evaluate as the same thing. That takes a while. I won't really get into that in this video. The second example, though, is really where things interesting start happening. If we're subtracting that whole set of terms, that whole trinomial, we are doing the same thing as subtracting each of those terms. So basically, we're going to distribute that subtraction. So if we melt away those brackets in the front, because we're not really doing any operations with those, we get 3x squared minus 5x plus 4. We are subtracting 2x squared, but an interesting thing happens here. If we're subtracting positive x, subtracting a positive x is the same thing as just straight up subtracting x. And subtracting a negative 7 is the same thing as just straight up adding a 7. So you'll notice that those signs actually do change a little bit when we are subtracting, because subtracting has that interesting property of changing signs or doing the opposite. Okay, so our collecting like terms step here is that 3x squared minus 2x squared is going to get us 1x squared. Don't need to write the 1 in front of it. Negative 5x minus x is going to be negative 6x, and positive 4 plus 7 is going to be positive 11. So here's another example, example C, where we're going to have to do some subtraction of some stuff and addition of some stuff. So I'll get you started, and then maybe you can pause the video when I tell you to. With the first set of brackets, again, we're not doing an operation with any of that stuff, so it basically winds up being 2x squared y minus 3xy plus 6y squared. We are going to subtract each of the terms that are inside of the brackets that are right in front of the subtraction. We're not going to over subtract, right? We're not going to subtract any of this stuff at the end, just the stuff that's in the brackets in front of it. So we're going to take away 5xy squared. We're going to take away negative 7xy, which is the same thing as adding 7xy. And we're also going to take away negative y squared, which is the same thing as adding y squared. We're also going to add now each one of these terms that we're tagging along at the end of that last trinomial. So we're going to add 6x squared y and add yx and subtract 10y squared. So you're probably getting the drift that adding a trinomial is going to be way easier than subtracting a trinomial, because if we're subtracting, we have to be careful about signs changing. If we're just adding, we can even melt away those brackets and it's not a big deal. The final step is to collect like terms. So if you want to pause the video, maybe the answer will magically appear for you. And so magically now you can see the answer here. I've color-coded it for you so you can see that the x squared y terms were underlined in purple, this one and this one. They got together and gave me 8x squared y. The xy terms were underlined in red. A little interesting trick here is that yx, you'll remember, is the same thing as xy, because order doesn't matter in multiplication. And underlined here was the xy squared term. There weren't any terms like it, so it basically remains unchanged. With a final example here, just to remind you, interestingly enough, about subtraction, is that order matters when we're subtracting. So be careful when you run into word problems with these. If I asked you to subtract 5x squared plus 7x minus 4 from 2x squared minus 5x plus 4, hopefully you'll remember that order would be 2x squared minus 5x plus 4. We would take all of that and we would subtract 5x squared plus 7x minus 4 from it. Okay, so just be aware of that. And again, if you want to pause the video now, the answer will magically show up. So pause your video now. All right, so as you can see with question D, magically I'm going to hide it one step after another, but you can see that I'm going to subtract each of those terms that are inside. So again, subtraction, a little bit of a red flag for us. Be careful, it's going to change some signs. So in my first line, you can see here that I've taken that subtraction and I have distributed it. So I'm going to take away 5x squared, as you can see. I'm going to take away positive 7x, so take away 7x. I'm going to take away a negative 4, which is basically a positive 4. Then I've color-coded my collecting like terms, so hopefully you don't have to go into too much detail with that. It was a pretty straightforward collecting like terms problem. So you'll notice that for the past little bit I've been using the word distributing. So part of this lesson is about distributive properties. So an interesting thing as well about cheating BEDMAS is actually that we discover that 2 bracket 3 plus 5 is actually the same thing as 2 bracket 3 plus 2 brackets 5, 2 times 3 and 2 times 5. Here's the proof, right? So 2 times bracket 3 plus 5 is 2 times 8, which works out to be 16, and 2 times 3, which is 6, plus 2 times 5, which is 10. Oh, 6 plus 10 is 16. So actually, if you were to pick up any numbers, any set of numbers in any combination, this actually works. So really neat, it's a way to cheat BEDMAS. So let's take a look at a few quick examples to sort of reinforce this concept. So if we're going to expand and then simplify where possible, that means expand to do distributive property. So dist for distributive property. Simplify is basically collect our like terms. So if we're going to expand the first expressions, we got 4 being multiplied by these two things that are unknown. If we wanted to cheat BEDMAS, we could take this 4 and we could multiply it by x, which is 4x, 4 times x, and 4 distributed to this, 4 times positive 5, which is plus 20. And that's equal to that. A little bit more difficult when we're dealing with a negative, for example, b, so negative 3 multiplied by positive 2x. So negative 3 times 2 is negative 6, and there aren't really any x's being multiplied, so x just keeps tagging along. Another interesting thing is when we're taking the negative 3 and we're multiplying it by negative 1, don't forget negative times a negative, that's a positive, positive 3. Finally, basically with example C, we're putting them both together. So maybe you want to pause your video now and take a look at examples C and D, give them a try, and the answers will magically appear in just a second. Okay, so there's the 2 answers to both of those problems. In question C, you can see in blue and in green, I've kind of color-coded my distributive properties. Notice that I'm doing 2 of them. So the negative 2 is only going to be multiplied by the stuff that's in front of it, and the 3 is only going to be multiplied by the stuff that's in front of it. Again, I color-coded the answers to both of those. You'll notice that there's stuff that can be collected. There are like terms that can be brought together. So the 14x and the 12x, they can get combined together, and the 6 and the negative 15. Again, it's all color-coded, so hopefully you can see. With question D, I just had the extra step as well, the extra set of brackets, but really nothing different, only there's a few more terms. So the whole point of this, the reason why we call it simplifying, is if you look at the first line of question D, I mean, there's a lot of terms bouncing around in there. There's a lot of math being done. If we cheat BEDMAS by doing the distributive property and then we collect our like terms, we actually get a much more simplified expression that is equal to what was above. So it's a little bit easier to do mathematics with that, and you'll see it's a lot easier to graph something that looks like that, and to do, problem solving with it. Okay, so this is just sort of a neat building block that you'll need in the future. So I hope you enjoyed this lesson on addition and subtraction of polynomials and distributive properties. So it's a mouthful, lots of stuff to consider. If you didn't quite get it, or if it went way over your head, probably try and watch the video again, maybe rewind it through some of the sections, and see if you can attempt some of those questions yourselves.